have a picture or not. Okay? And the way it doesn't matter, if I look at GM and MT, what letter do they have in common? M. Was that the answer to our question, number one? It's angle M, right? Okay. Now, if I'm trying to figure out which sides make angle T or include angle T, which letters have we not used yet? In this question, which letters am I not talking about? M and G, right? So if I say M and T, G and T, knowing that the segments have to have T to make angle T, then the other letters with T make up the two segments. And that last one, using that idea, what letter do they share? G is in both of them, right? So that idea, those questions can be answered regardless of having a picture. Okay? The remaining questions here, guys, were just yes or no questions. If yes, you say why, side, angle, side, or side, side, side. Okay? So we look at number 4, and we did this one in class, but we came up with this being side, side, angle, and this one being side, side, angle, right? And that does not match either of these. So we write not enough information. Does that mean those triangles are not congruent? No. Okay? Remember, saying that we don't have enough information is not creating a situation where you can say the opposite of what you're trying to prove. We're trying to prove them congruent. I don't have enough information. That does not allow you to say that they're not congruent. It's just you don't know yet. Okay? You got to keep working, keep trying to figure out more congruencies so that you do get one of these two situations to occur. So it's not enough information. What about number 5? Is that enough information? Is that segment in both triangles? So do I have side, angle, side in that triangle? And side, angle, side in that triangle? So we would say yes, those are congruent. What about number 6? Yes or no? Yes? Why? Side, side, side? Yeah, the hope is there's about 20 people yelling side, side, side. That should be a pretty obvious thing there. What about this one? ZY is in both, right? But is that the same picture as what we had up here in number 4, essentially? You got side, side, and then the angle, right? Does everybody agree that that angle in my picture is not between my two sides? The angle that would be between my two sides would be that angle there, right? So when I write the ordering of parts, I want to make sure that the angle is not between those, okay? I think we talked about this last week. I could write it that way, but probably shouldn't, right? Okay? Side-side angle is not a congruency statement. So not enough information. What about 8? Side, side, side. What about 9? Side, angle, side, good. What about 10? Not enough information. And we can say NR is congruent to NR, right? Okay. So what we would need to be able to do is show maybe that side there, congruent to that side there, to go side, angle, side. But we don't have anything up there to tell us that that would be true. Okay. So not enough info. Well, those two. Side, angle, side. What do you know about that angle there compared to that angle there? Vertical, right? Okay. And that one. Side, side, side. Explicitly side, 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 right? From everything they gave us, side, side, side. Do you agree with that angle is congruent to that angle? Anybody say side, angle, side? Because it works. Okay. We're going to find out. There will be a couple proofs later on, probably towards the end of the chapter, where there could be two triangles that are legitimately congruent by like 3 or 4 different reasons. Okay? where you are doing the proof. Maybe you use side angle side, your neighbor's doing the proof, maybe they use angle side angle, and your third neighbor is doing the proof and they found side side side, but you're all correct. Okay? You guys have questions on that stuff? Is this something we can visualize and see and recognize and understand? And then remember, once we know that the triangles are congruent, so all of these that said yes on them, we can go back and we should be able to list all three sets of angles that are congruent and all three sets of sides that are congruent individually. Okay? And that's the CPCTC idea. So if we understand that concept, guys, today's stuff is not really new. Okay? We're going to still talk about, so the idea, the overarching concept here is triangle congruency. Okay? By trying to find three sets of parts that are congruent. Okay? This is just a different ordering of those parts. All right? And I think by kind of what we've already done, you know that ASA is an angle followed by a side followed by an angle, right? And angle F is an angle followed by an angle and then a side that is essentially not between the two angles. Okay? So these are going to be two more tools for us in regards to proving triangles congruent. Angle side angle and angle side. When we, and I'll put the postures up there for you in a moment. When we talk about these, and you're not going to see this, but only in the angle side one. If I say SSS, is that the same forwards and backwards? Okay. If I say SAS, is that forwards and backwards the same thing? Okay. You guys know what kind of words you can read forwards and backwards? Like mom, dad, race car. Those words are called? Is it race car forwards and backwards spelled the same way? Okay. Okay. You guys know, so that's a group of words, they're called palindromes, okay, that are that way, okay? So, as acronyms, side, angle, those are palindromes. So when I write them forwards and backwards, there's really no difference, right? Okay. When I go angle, side, that one, when I go backwards, is side, angle, right? So in some texts, you might use angle, side. That's what the author prefers it. Other texts call it side, angle, okay? They're the same thing, okay? Obviously, you don't have angle, side, angle, forward and backwards, so another I know on here, okay? Those are, ultimately, guys, the four structures of parts for sides and angles that are going to guarantee triangles to be congruent, okay? The one that we've talked about already that doesn't guarantee triangles congruent was that question number 4 from that worksheet, was when we have side, angle. Okay, I should write that here. Side, angle does not guarantee congruency. These guarantee triangle congruency. These do not guarantee triangle congruency. Okay? Just because they do not guarantee triangle congruency does not mean that when I have those parts, the triangles are not congruent. It just means I'm not sure. I can't 100% confirm that. Okay? So that's one of them. And the way I remember that one is, if I write it backwards, I shouldn't write that, so it shouldn't be a congruency. Okay? The other one, what are the only ordering of parts that we haven't used yet? We use side, angle, side. We use 3 letters of S, 2 letters of S, 1 letter of S,
So that's 0 A's, 1 A, 2 A's, 2 A's. I use all 3 A's. Angle, angle, angle. That does not guarantee congruency. Okay? You guys use the buttons on your calculator, sine, cosine, and tangent. SIN, COS, TAN. You guys ever used those before? Okay? The reason those work is that angle, angle, angle relationship, which guarantees what we call similarity. Somebody in the last class asked why this is the case, so I have this. So I'm going to kind of talk about this real quick. Let's dilate that, about that, by a factor of 2. All right, so would you guys agree that those are the same shape? Both triangles? Obviously different sizes, right? Okay. Let's see here. How did I do that? There we go. All right. So same shape, different sizes. So that contradicts the definition of congruency. So those two triangles are definitely not congruent. However, if we were to take these two triangles and put them on top of one another, would you agree that those angles down there at the bottom do end up matching up? Does that make sense? So there's one angle congruent to one angle. Would you agree that the angles at C end up matching up? There's a second angle congruent to a second angle. And then a third angle congruent to a third angle, right? Does that make sense, everybody? So that's a situation where these two triangles, when I move them on top of one another, come on, now it won't let me move them. There we go. When I move them on top of one another, I can confirm that 3 angles are congruent to 3 angles. So I have angle, angle, angle. But obviously, at the start, we knew that those were triangles that were different sizes, so they're not congruent. Okay? However, what I want you to understand is that that does not guarantee that the triangles are incongruent. Okay? Because I could have that triangle and that triangle. The only thing I know, if I match these up, would you guys agree that A and A1 match up? Would you agree that B and B1 match up? Would you agree that C and C1 match up, right? So that would be a situation where I've got angle, angle, angle. Both the triangles are congruent. Okay? So we got a situation where angle, angle, angle exists, the triangles are congruent, and we got a situation where angle, angle, angle exists, and the triangles are not congruent. So overall, when we have angle, 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 we just don't know. We could have one or the other situation occurring. Okay? And that's the same thing with side-side angle. You might have two triangles that are congruent, but there's also a situation where you might have two triangles that are non-congruent or incongruent. Okay? The ones on the board up there on the left in blue and purple, those will guarantee, with those parts, they guarantee the two triangles to be the same. Okay? So we need to commit those listings of parts to memory. And I'll let you write down these two postulates before we do any work, but it says, angle, side, angle, and this is my hope, is that we understood what side, angle, side was. So angle, side, angle is just taking the word side out of side, angle, side, replacing it with angle, and taking the word angle out of side, angle, side, and replacing it with side. And gets you this postulate. Okay? So angle, side, angle means your side now has to be stuck between two angles. The side that we know information about, the side we know congruencies about, is now between your two angles. Does that make sense? If you look at this picture, does that make sense? Like angle A and C, they are the two angles that are being marked. We agree that AC would be the side between them. It's also, sometimes you'll look at it as, or it would be described as the ray that is shared by your two angles. So AC is a ray of both angle A and angle C, the overlapping ray, overlapping side of the angles. Sometimes that's how we define an included side. But if you have that order of parts, then that guarantees you for the triangles to be congruent. If I give you that angle, I give you this side, these sides are kind of cruddy, being green, let's make them red. I give you the red side of 5.74, and I give you this blue angle then of 43.72. And those are the things that you use to reproduce an image over here, right? So I know I've guaranteed myself an angle of 79.6 here. I've guaranteed myself over here 43.72, and they are basically 5.74 units away from each other. Is that okay? If you project taking a segment and just kind of lining it up there, does that kind of make sense? Extend that segment forever, and then take this one here and extend along there. Do those connect at a point up here? Is that point essentially the same as that point C right there? Does that make sense? Okay. Every single time that you have angle, side, angle, that extension of those third sides that we know nothing about will indeed intersect that. In this case, I call it point P, but point P then corresponds to angle C, or point C. Now, if we were to go through, now I never worried about these other measurements. If I try to find that angle measurement right there, and then that angle measurement right there, they're the same, right? I never worried about finding or using distance AC. It was 4.75. This distance I had no idea about. But once I find this point P, that distance is, here's the Q to P, is 4.75. When I do that one, 6.76, and then P to R, 6.76. That kind of makes sense, everybody? So angle, side, angle is always guaranteed no matter how I move these around. You can see that second triangle, once it's constructed, is always the same as the first one, no matter what. Okay? Even like this, they're the same. Okay? They're just inverted from one another. All right. So that's angle, side, angle. The other one, so just kind of talking about the included side, just to make sure we're on the same page with that. Okay? Included sides, similar to included angles. It's just now the side that is stuck between two identified angles. You don't need to maybe write this down. Be able to identify them. If those are my two angles, O and N, then I'm going to identify for you. What's the segment that is between them? Do you guys agree that ON is the segment between them? Okay. That would be the included side. So then, because this will be important as well down the road, that side and that side, are they included? Are they between the two angles? No, right? Okay. We call those non-included sides. Okay, so that's something to kind of think about, because some of our statements, some of our postulates here in a moment are going to use the word non-included. Okay, a more kind of maybe common word for you to use would be excluded, right? You're either included or excluded. Okay, math textbooks though don't use that word excluded; they use non-included. Okay, just kind of keeping consistent with. Whenever I want to essentially negate something, I put the word non out in front. Okay. Why is that important? Non-included sides, because we get down to this theorem here. And this is a theorem. This is actually something we could prove, and we might maybe tomorrow. The other ones so far, side, angle, side, angle, they have been postulates. They be things that we take for granted. We can show diagrams and pictures like we have. But this is a theorem. This can be proven. Okay? So if two angles in a non-included side. Okay? So that means when I write my list of parts, the S is not going to be between the A's. Okay? It's got to be after the A's or before the A's. Okay? So AAS or SAA. Okay? If that's the case, we have two angles in a non-included side congruent to two angles in a non-included side. Then the two triangles are guaranteed to be congruent. And the proof of that is really easy. Okay? We're kind of talking about, maybe just briefly discuss it here. If I start off with two angles congruent to two angles, two angles congruent to two angles, much like we've got in this picture here, what do you automatically know then about angle C and angle F? If I know angle A is congruent to angle D, angle B is congruent to angle E, what do you know about the last two angles in both triangles? They got to be congruent, right? Or two, right? Okay. So if I looked at C is congruent to F, and don't even worry about the markings in B and E, okay, when I have angle, side, angle right there with A, AC, and C, compared to over here with D to DF and F, does that make sense? You have angle, side, angle, angle, side, angle. So because when you have angle, angle, side, you automatically, with the third angle theorem, also have angle, side, angle. Okay? So that's why this theorem is true, because it's ultimately angle, side, angle. Okay? We okay with that idea? So as we do our proofs, guys, things that we're on the lookout for. Okay? Those four things. And I told you last week that there will be one more. There's a total of 5 things that we're allowed to use to show triangles congruent. And it's going to occur in right triangles. So it'll be a little bit special. We'll talk about hypotenuses. So we use some different letters. But that right now, any set of triangles that we're going to try to show congruent, those will be our tools to do that. Okay? And we just got to make sure that we're able to order them in the right order, make sure that they have substance in regards to why we know certain segments are congruent to certain segments and certain angles congruent to certain angles. You can't just haphazardly, because that's what you want, say that they're congruent. There has to be reason behind those congruencies. But that's the set of 4 statements that allow us to show triangles congruent. So what I want to do with you is, I've got at least 2 proofs here. This is exactly the same as the first proof we did on Tuesday of last week, except I think this last statement was something about B being a midpoint of AC. I'm going to redesign it a little bit, okay? But the picture is the same. The first part of given information is the same. And the prove statement is the same. And my hopes are, even though we changed this purple part, my hopes are that you realize that most of the proof is identical to what we've already done. Okay? As we go through proofs over and over and over again in this class, you're going to hear me talk about, we've already done this, we've already done this, we've mentioned this before, remember doing this Tuesday, remember doing this Monday. Because hopefully we can connect the dots and realize that this is progressive. Everything is building off of what we've already learned. Okay? I don't want you to encounter something and think it's 100% new to you. All right, what is this vocabulary word right here? Perpendicular. Okay? So here's where knowing what we did last Tuesday or Wednesday comes into play. Last time we saw the word perpendicular, we wrote about the types of angles that they gave us. So it's a pattern. I want to do the same thing. If DB is perpendicular to AC, what kind of angles do I get? Perpendicular lines always create right angles. Okay? So I'm going to say that, and if I go find where DB is in AC, that means that's going to be a right angle right there, correct? I need to identify it. I'm going to say angle ABD and angle CBD are right angles. And that's the definition of perpendicular lines. Okay? Someone will ask us, why can't I say ABD and CBD equal 90 degrees? And the reason for that, because I would argue, and most of you probably agree, that is a condition that happens with right angles. But if I were to look up the definition perpendicular lines, nowhere in the definition of perpendicular lines does it use the number 9 followed by the number 0 followed by a degree symbol. Does that make sense? All it says in the definition is they make right angles. So if somebody's reading my work that has no idea what we're talking about, maybe they don't know what 90-degree angles, they don't know that condition about right angles that they're 90 degrees, and you wrote 90 degrees, they get lost. Okay, does that make sense? Okay, so we want to write down what the definition really says. If you remember from last week, once we wrote that down, what did we say about that angle compared to that one? Because they're both right angles, they have to be what to one another? They have to be congruent. So angle ABD is congruent to angle CBD because they're both right angles, right? So we had an argument that said all right angles are congruent. At that stage last week, I told you that's a pattern. When you say you have two angles that are right angles, you always say that they're congruent to one another. That's what we did here again. It's a pattern. Okay? I'm going to let the picture and draw that stuff in. So those marks and those angles. Okay? The next vocabulary word. What's the next vocabulary word up there? Bisects, right? Bisects means what? Splits two equal parts. Okay, so now we just got to figure out what we're splitting. Because we have bisectors for segments and we have bisectors for angles, right? So this is an angle bisector, so we should get two equal angles. So I'm going to look up here. They're talking about ADC. ADC is that entire purple angle, pink angle, whatever color that is. The two individual parts then would be that part and that part, right? So I'm going to say angle ADB is congruent to angle CDB. And that's going to be definition of an angle bisector. All right. So here, and then we're going to do this in a couple of examples here in a moment as well. But look at this picture. We have two angles congruent to two angles, right? I'm going through my list of things I'm allowed to use. That is obviously kind of a dumb one to use, right? Side, side, side. If I was going to try to use side, side, side here, all the work that I've done right now is pointless in using side, side, side. Okay? If I want to use side, angle, side, one of those angles up there is nice, but the other one was useless. I think it probably comes down to these two, doesn't it? And now I've got to figure out, is my side that I'm going to use, is it between the two angles, or is it not between the two angles? So I look at my picture and see if my picture provides me any useful information. And what pattern have we seen over and over and over again with our pictures in regards to segments that are being shared? What can I say about DB? It's reflexive, right? It's congruent to itself. So let's say step 5, DB congruent to DB. Reflexive. And now what is the order of parts that you have in those two pictures? Where was the side located? Was it between your angles or not between your angles? It was between them, right? So step 6, I'm going to say triangle ABD congruent to triangle CBD. And because the order of parts here was an angle followed by a side followed by an angle, same thing here. So my reason is ASA. Is that what I wanted to prove? It wasn't, was it? So the next thing, what is this reason right here going to be before we even write down what the statement is? Remember that, CP, CTC? Okay, we said 99.9 repeating % of the time. If you've got to follow an ASA, SSS, SAS statement, it's going to be followed by CP, CTC. Off the top of my head, I can't even think of a reason why you would not follow it by that. Okay, so this might actually be 100%. Okay, if I look at this, would you agree that AD, first and last letters there, CD, first and last letters there, right? So AD is congruent to CD by CP, CTC. And again, and we had this discussion last time, we did this problem. What could I call that triangle? Now that I've got that segment there congruent to that segment there, what could I call that triangle? If you have a triangle, the overall triangle ADC. If you've got two sides congruent, it's got to by definition be a isosceles triangle. If you remember, we can go back to the picture. If you remember, I think what I did was I took this out here and I asked you, what is that overall triangle? You got two sides congruent, It's isosceles. Okay. So what's that tell me? Well, that tells me if that's isosceles, then every time that I'm provided that segment right there as an angle bisector, okay, of an isosceles triangle, it's going to have to be perpendicular down here at the bottom. Okay, and we'll have an entire section devoted to that. But this is what this leading to, guys. Trying to figure out key information about other facts, other figures, maybe other triangles, based on knowing congruencies of smaller triangles. Okay. Let's do this one real quick. This didn't copy over very well. That's a congruent symbol there. Congruent symbol. What's the vocabulary word up there? Congruent is a vocabulary word, but but that doesn't get me anything new. Yeah, that one right there. Parallel is what we're looking for. Okay. When I see the word parallel, this is a little bit different than any other vocabulary word that we've seen. We're never going to use definition of parallel. because that just says it's two copointed lines that don't intersect. But when we talk about parallel lines, something that should hit your memory is the word transversal, right? When I see parallel lines, I should think transversal. When I think transversal, I should think alternate interior, alternate exterior, corresponding same side interior. Okay? And the number one, I'm not going to say this is going to work every single time, but the one that seems to show up the most in a lot of proofs is alternate interior angles. So knowing that piece of information, that's what I usually look for first. Just through experience, I know those show up a lot. Okay? They might not, and I might have to go to one of the other ones, but if I'm trying to be efficient, that's what I'm going to think about. Now, how do I know which transversal to look at? If I look at my parallel lines, okay, these ones on the left and right, there's three transversals. I think it makes most sense, and again, this isn't going to work all the time, but most of the time it does. I'm going to focus on the transversal that is common to both triangles. The transversal that belongs to both triangles, that forms a side for both triangles. If I look at WR as my transversal, does that tell you something about that angle right there and that angle right there? What kind of angles are they? Alternate interior. Okay? So that's what we're going to write. Now, I can't just say angle W and angle R, because there's three angles at W here. Okay? So I'm going to say angle MWR is congruent to angle, so MWR, what we got the other, KRW, or WRK, however you want to say it. That's the alternate interior angles theorem. So now in our picture, we have that angle congruent to that angle. We have, what's it, MWR, so that angle there, congruent to that angle there. Okay, so now using our tools, hopefully we agree that that one's useless. Because all the work then that I've done so far, I basically have to start over. I don't have any congruencies that are going to allow me to use that. Same thing here, side angle side, better than side, 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 but I don't have any sides yet, so I'm not going to try that one. It gets me down to these two, the two that have angles in them. Okay? If I've got angle, side, angle, or angle, angle, side, I'm going to look at my picture and looking for the third side, okay, the third congruency. Do we know that this side here, based off of patterns, is something we always want to look at? Shared by both triangles. So we're going to say WR congruent to WR. What's that reason? Reflexive. What's the order of parts now up here? How many angles do you have? In that top triangle, you have two angles, right? Is the side between those angles, or is it non-included? Non-included, right? So it's got to be at the end or at the beginning, doesn't matter. And then the same thing over here. I've got two angles, but the side is not between them. So I've got enough to say that these triangles are congruent. So step 4, WMR congruent to RKW. And the reason is angle, angle, side. Where is this going to lead us? Eventually, guys, that's going to allow us, would you guys agree that M to W and R to K, M to W and R to K would be congruent by CP/CTC? And when you have a quadrilateral where one of the sets of opposite sides are, in this case, they start off being parallel and they're congruent, that will lead us to knowing that that quadrilateral up there is a parallelogram. It's going to make the top and bottom also parallel. And that's where this is going to kind of parlay into Chapter 5, Chapter 6, Chapter 7. By using these triangle congruencies, we're going to learn stuff about other shapes. Okay? 4.3, online, Math Excel, give that a shot. Shouldn't be should be just about like 4-2 was, but you're going to be using angle side, and angle side predominantly. Okay, so just make sure you get that one finished for tomorrow. It's for tomorrow evening. If we're in class tomorrow, we'll discuss it if we need to.